Hello guys! Hello everybody! Welcome back to my YT channel. Let's do the problem solvings of chemical reaction engineering problems and chemical reaction kinetics. So I am done with formulas, equations, theories, principles, and concepts, the basic foundations of the solve this problem solving related to chemical kinetics. Okay, now we have the problem here. Problem number 1. Let's try first two problems. Okay, like this. Okay, I will read for you. Dinitrogen pentoxide decomposes into nitrogen dioxide and oxygen gas. If the average rate of disappearance of NO2 is 4.6 times 10 to the negative 3 mole per liter second, what is the average rate of disappearance of dinitrogen pentoxide? Oh, asking for the average rate of disappearance. What do you mean by this? Let's have the data. Reaction first, chemical reaction first. Dinitrogen pentoxide, okay? What do you mean by that? Pentoxide meaning 5. Di mean 2. So dinitrogen meaning say N2. So N2. Pentoxide meaning oxide, oxygen. So there are 5 oxygen atoms. So N2O5. Okay, like this. This is nitrogen pentoxide. Okay, now nitrogen dioxide N2O5 or nitrogen pentoxide decomposes into nitrogen dioxide, meaning it will produce nitrogen dioxide is in O2 because dioxide subscript of 2. Okay, nitrogen dioxide. Okay, then and oxygen gas. When we mean of gas, that's automatically the diatomic molecule of oxygen, not the single, the O only, the O2. Okay? Because we have also O3, the ozone. And we have also the O only, which not reactive, only for the purpose of balancing like this or any redox equation. You have to put only O, oxygen, without any subscript. That means O1. But that is not used in the chemical reactions. Okay, it will never be exist. It always exists as O2 or oxygen gas in a chemical reaction. For the purpose of O1 only or O is for the balancing situation. Oxygen, the left side, oxygen, the right side. You don't have to put O2 when you say that. Elemental accounting of the number of atoms in the reactant and the product. You'll never say oxygen gas in the left, oxygen gas in the right, or O2 in the left, O2 in the right. You'll never say that. You will never say oxygen in the left, oxygen in the right, right? But in a chemical reaction, you will never say that also, oxygen. Okay? The oxygen there in the reaction will always be automatically oxygen gas. Okay? Like that. Oxygen gas is always O2. Okay, if it is O1, that is not a gaseous state. That's only elemental for the purpose of balancing the chemical equation, something like that. Okay? Monoatomic. But this is diatomic oxygen. Oxygen gas. If we mean oxygen gas, O2 directly, without question. Okay? And you can never see also in chemical reactions, oxygen in your chemical reactions. Okay? Like that. Okay, this one. So N2O5 nitrogen pentoxide equals to nitrogen dioxide plus O2. Is this balanced? You have to balance first, of course. Because number of moles here is very important because we are dealing with the rate flow, the rate of chemical reaction, and then the rate constant, and it matters a lot also. Okay? Especially stoichiometry. Okay? Okay, now, balance the oxygen here. How can we do this? Okay, start with nitrogen. Okay, we have to, let's do direct because I no need have time to use algebraic expression by following the law of conservation of matter or mass. No, it's not, because our focus is reaction kinetics, so we need to balance this directly by visualization. Okay, so N2 in the left, so N2 we have to put 2 on the right. Okay, N2, so 4 plus 6. Okay, so ganon. Okay. Okay. So, Balance or not? The oxygen. It's not balanced, okay, because the oxygen in the other side is 5. So how can we do this? Okay, so let's have, okay, 5 here. Oxygen in the left is 5. And then the other one is 4 plus 2. So there's a deficit of 1 in the reactant. Okay? So we need to add 1. But since we cannot add 1 directly because that's to add ODD. Okay? So we need to let X as the number of moles of oxygen gas in the nitrogen pentoxide. So X. So it's gonna be 5 times X is equals to 6, like this. So our X will be 6 over 5. Okay. And then, if our X is equals to 6 over 5, then put that here in the X. Okay, so it's gonna be 6 over 5. And then balance again the chemical equation. Since this is fraction, you have to cancel out the 5 denominator. Multiply both sides by 5. Like this. It's gonna be 30 N2O5 is equals to 10 NO2 and 10 oxygen gas. No, 5 lang siya. Sorry. 5 oxygen gas. 5 times 2, 10 NO2. 5 oxygen gas and 30 N2O5. This one. This is our... Okay. We get X 6 over 5 due to the law of conservation of matter in chemistry. And then our X is beside here. Our X is beside here in the reactant because this is the deficient one of the 1 mole of oxygen gas, or no, it's not mole, atom, something like that. Okay, so you have to undergo the linear mathematical expression and solve for the value of X. So our number of atoms is 6 over 5. Put that here in the coefficient of the nitrogen pentoxide. Now, since you need to avoid fraction in your chemical reaction, multiply both sides by 5. It will cancel out. It will become 5 times 6, 30. 30 in pentoxide. And then 5 times 2, 10 nitrogen dioxide plus 5 oxygen gas. Now, what you see here is we need to simplify. Use the least common denominator in mathematics. So, can we divide this by a least common denominator? 30, 10, and 5. So, use 5. Okay, so 5 divided by 30 is 6. Okay. Again, this is our first attempt. Okay? Mahilig kayo sa attempt. 30 divided by... Okay, so divided by both sides by 5. 1 over 5. Sorry. Or 5. 1 over 5. Okay? So 30 divided by 5 is 6. 6 nitrogen pentoxide. The purpose of this, guys, is to balance, really, to get the number of moles. Now, if you keep on balancing and balancing and balancing, it will never be balanced. The only assumption for that, you have wrong chemical reactions. Take note, you have a wrong chemical reactions because your procedure in balancing the chemical reaction is correct. But still, you produce so many attempts in your balancing of equation using algebraic expression as per the law of conservation of matter, then your chemical reactions are wrong. Especially in this occasion, that problem doesn't give the chemical formula in the chemical reaction. It's only statement here. And then if I will have a wrong statement, automatically my chemical reaction will be wrong. That's why I investigate at first here. Nitrogen pentoxide, like this. Okay, let's see. Okay, so 6 into O5. So 10 divided by 5 is 2. 2 NO2. And then 2 NO2. That is oxygen gas. Okay, guys? This one. And now, second balancing of the number of atoms. So, N, like this. Okay. So, N, we should balance again. Okay, balance again. So 30 divided by 2, no, 30 divided by 5 is 6. Okay, N2 is 12. The N2 on the other side, how much? It's deficit. Deficit meaning kulang. Kulang siya of 10. I'll just put arrow down. Kulang siya 10. Okay, so balance immediately because the gas will be balanced last. Okay, now, so let the value of X is the number of atoms in the deficient one. It's in the product, the deficient of oxygen. So we need to put that in the priority to the oxygen gas. Do that in the solo element oxygen first, not on the compound. That's the procedure. Go first with the solo elemental oxygen to put the value of X, not on the compound. If there's no other choice, that's the time you will put the X atoms in the compound. But in here, there's a solo flight element, which is an oxygen. Put the X there beside oxygen. So, X oxygen gas. Now, do the equilibrium law of conservation of matter. So, we have 12 equilibrium equal, okay, so 12 equal equilibrium is equals to 2, okay, like this. We balance the, we balance the nitrogen, not the oxygen pa. Nitrogen pa. So, ang kulang of 10 ang nitrogen, not the oxygen. Advanced kaayo po, in fairness. Okay? Into, madali man po. Charot! Okay, 10. So, like this. Of course, you have to put X in the nitrogen. So, X in the compound in O2. Okay, like this. So, 12 is equals to 2x. Okay, 2x. Okay, like this. So for the value of x, 12. 6. X is equals to 6. Ganon. Yes. Put the 6 in the beside the nitrogen. Right? Like this. Okay, so that is 6. So this become 6 into O5, 12 in O2 plus oxygen gas. So balance again for the third time. Nitrogen is 12, nitrogen is 12, balance. Oxygen is 30, 24 plus, here is lacking siya 6, then so plus 6, automatically times 3 na siya. Okay, so this is gonna be like this. Okay, so nitrogen 12, nitrogen 12, oxygen 30, oxygen is equals to 24 plus 6 is equals to 30. Okay, this is our third attempt, balancing. Now, we obtained 6 nitrogen pentoxide, 6 moles of nitrogen pentoxide plus 12 moles of nitrogen dioxide plus 3 moles of oxygen gas. Now, get again the less common denominator. Try if it can be divided by the common. Here, it's very obvious you can divide by 3 all. So, 6 divided by 3, okay, 2 and 2, 5 is equals to 12 divided by 3 is equal to 4 in O2, and 3 divided by 3 is oxygen gas, is 1 mole of oxygen. Now balance again for the 4th time. Okay, this one. So start with nitrogen again. Nitrogen is 4. Let's try, right? Ganun talaga ang buhay. Charot! Okay, nitrogen 4, oxygen is 10. And then the other side, nitrogen is 4. Oxygen is, let's say, 10. Perfect! Balance siya. Okay, it's gonna be like this. Na-balance good siya for the third attempts. So this kind of chemical reactions requires 3 attempts to balance the chemical reaction. Starting from the fractional form and then going back to the numerical form. See? So this is the reason why it makes difficult for others to balance. Because they will surrender after first attempt and second attempt. Guys, you will never surrender until let's say 5 maximum attempts. Okay? If you feel that still you cannot solve the chemical equation or reaction, then there's something wrong with your chemical reactions, the formulations of the chemical. But in here, we have a perfect chemical reaction, because I know this, okay, because this is not difficult chemical reactions only, okay, so I know that confident that the chemical reaction is really correct. Then when I do the first attempt, second attempt, third attempt, it will now balance perfectly. So this is gonna be like this. Okay, so 2 moles of nitrogen pentoxide plus 4 moles of nitrogen dioxide plus 1 mole of oxygen gas. Now guys, be patient, okay, so that we can achieve a balanced chemical equation before we proceed further what is being required. In here, the average rate of this appearance is the one we are asking for. So what is average rate of this appearance of dinitrogen pentoxide? Okay, the dinitrogen pentoxide, the N2O5, we're not very lucky here because the statements not given in the chemical reaction. We are not lucky. We are only very lucky if the chemical reaction will be given and if it is balanced also right away. But in here, all is not being presented. Okay, so we will be the one to do. Okay, something like that. Now, in here, the average rate of this appearance is the same as the rate. Okay, the rate, or shall we say, the delta change of the concentration of nitrogen pentoxide over the delta change of time. Okay, now, this is 2N2O5 for NO2 plus oxygen gas. The reaction for this, okay, this is still under unimolecular chemical reaction. Why? Because there is only one reactant to produce 2 products. In accounting, if it is a unimolecular chemical reaction, okay, or let's say bimolecular chemical reaction, thermolecular reaction, or trimolecular reaction, it's just the same with thermolecular reaction, right? And we based on the reactants, how many reactants that we have. The products are not our bases. Okay? So in here, one reactant, which is nitrogen pentoxide, so automatically this unimolecular chemical reaction. So our rate law will be rate constant times, close and open parenthesis, the concentration of N2O5. Okay, here, because reactant, okay, reactant always. And then some students, including me before, will raise this to the 2 because there's a 2 coefficient of 2. No, it's not the number of moles, it's the reaction order. You have to put X or Y to solve for that. Okay, let the value of X first. Okay, so rate law or rate of chemical reaction will be the rate constant times 2 the concentration raised to the power X or Y if you want, or you can designate any letter if you want. But in here, it's very basic to use X usually. Right, in mathematics or in chemistry, X should be the basis, and then later Y, something like that. Okay, but never raise that to the 2 because the 2 is the number of moles. The number of moles is not equal to the reaction order N. Okay, but in here we just put X and Y because N is too general. Why? Because we have A and B, something like that. Okay, something like that. Okay, so raise to the power X. Muna na siya itong rate law. This one. Rate law or rate of chemical reactions was okay. N2O5 raised to the power X. Can we use this formula in solving of the average rate of this appearance? Can we use this? Let's see. Okay, let's see. Let's analyze. Okay, like that. Okay. Our given guys is 4.6 times 10 to the negative 3 mole per liter second. This is our rate of this appearance of NO2. Rate small r. Rate small r or delta change of NO2 over delta change time. Like this. Our rate small r delta change of NO2 over delta change of time, which is equal to 4.6 times 10 to the negative 3 moles per liter second. Okay, 4.6 times 10 to the negative 3 mole liter per second. This is our rate. Okay? Now, that is rate of disappearance. What do you understand by that? If it is disappearing, supposedly it is negative. Right? So, we have an option negative. So, let's assume that it's negative. Okay? Because disappearance. That's why we have analysis, right? We don't go directly on what on our mind because it's analysis first. Okay? So, let's say negative because this is the disappearance, right? We don't know. Okay? So, negative 4.6 times 10 to the negative 3 mole liter per second. Okay? Because this disappearance of NO2. Now, the unit moles per liter per second, what do you... It's not also very common because in a rate law, chemical reaction kinetics, it's usually expressed in molar, capital M per second. But it's just the same because this is just breakdown because molar is just equals to moles per liter. But my point is, in presenting so many problems in examination, it's usually expressed in capital M over second, not the mole liter per second. But in here, it is being breaking down into moles per liter per second, in which equal na siya. But what I mean, if di ka sanay ana nga pagka-present for that unit, sometimes you will be confused. Okay? Especially if you are too dependent on what is being used by our instructors and professors. And when you meet that kind of, variable, you will be shocked. Where did this come from? Like this. And that's the time you will investigate. It's just the same. Right? It's just the same as capital M molar per second. Okay, or molar times S negative 1. You will just transpose the S into the numerator, it will become negative. Okay, it's just the same. Okay, now we have this one, Now, we have the rate here, our K is equals to into O5X, right? Here, like this. And then, what is the disappearance of dinitrogen pentoxide? It's also negative for the pentoxide. So we are asked for rate of disappearance for dinitrogen pentoxide, which is also negative. So it's equals to R D N2O5 over dt, in which we don't know. Right? We don't know. Okay, that is X or question mark because we don't know, right? Okay. Now, we can guess or we can feel that this kind of problem was not done experimentally because there's no table representation from the initial concentration. Okay? So that's your first identification. It's gonna be not the initial concentration method problem solving because there's no table representation and there's only rate law emphasized in the problem. And in fact, there's no final concentration and there's also no initial concentration. So we will not force ourselves to use that initial concentration determination solution. Okay? So we go back to the traditional and conventional stoichiometric chemical calculation. Through the chemical reactions I balance here. Okay? That 2 moles of N2O5 will produce 4 moles of NO2 plus oxygen gas. And now, what is the average rate of disappearance of the nitrogen pentoxide? So, what is the average rate of disappearance of N2O5 if it is in equilibrium to the rate of the disappearance of NO2? Okay? So that you can equate the two behavior. Because the NO2 is in the product and the nitrogen pentoxide is the reactant. So we need to follow the law of conservation of matter in chemistry, that it should be in equilibrium with each other to solve for one quantity over the other. Or else, we don't have to do that. We don't have to find any quantities if we will not meet the law of conservation of matter. Okay? Like that. Okay? So, we will say R1 is equals to R2. Well, basically ratio and proportion. This is the first approach. We use ratio and proportion in algebraic expression muna before the stoichiometric way of solving. So, I will put R1 to the rate of disappearance of NO2 in the product. Okay. And I will put R2 in the rate of disappearance for the reactant, which is a dinitrogen pentoxide, in which I don't know the rate, right? So, ratio and quotient. Okay, something like that. Okay, R1 is equals to negative 4.6 and to negative 3 as our rate in 1. Okay, so R1 over negative 4.6, ratio and proportion only. Okay, times 10 to the negative 3. And we will also state in the other side in equilibrium to R2 over we don't know, right? Because the rate we don't know, right? So R2 is equals to we don't know. So question mark, or we can put that as X again, X. So we need to solve for the value of X, our rate. Okay, like that. Okay. Now guys, since you have 0.1, you have 0.2, and you have R1, you have the data. So in here, you will be able, or you'll be directed to consider the chemical reaction because there's no other choice. Because there are 1, 2, 3, there are a lot of missing quantities to be solved. Something like that. Okay? So we use the NO2 as our basis of calculation. The rate of disappearance of NO2 will be our basis of calculation. Okay? Linked to the chemical reaction. Now start with the rate which is negative 4.6 times 10 to negative 3 moliliter per second. Okay, this is our basis of calculation. Okay, so negative. Never mind with the signs. Later we will investigate because it's a theory concept na ang mga sign effect. Okay, it will be reduced, it will be increased, it will disappear, it will be appear. If it will appear positive, it will be disappear negative. It will be reduced negative, it will be increasing positive, just like theory concepts na lang na siya. But let's do first the mathematical expression. Okay, negative 4.6 times 10 to the negative 3 moliliter per second. Now, look at the chemical reaction, the balanced chemical reaction. This one. And now, since our basis of calculation is NO2, your denominator should also be NO2 so that it will cancel out. So, since there is mole in the numerator, in the rate, so you will multiply this to the quantitative relationship for NO2 versus the nitrogen pentoxide with mole also, but in the denominator to cancel that out. The mole relationship between the NO2 and the nitrogen pentoxide. So, mole of NO2 in the chemical reaction, we have 4 moles of NO2. So, put the 4 moles in the denominator. Okay, 4 moles of NO2 so that it will cancel out somewhere along the way in the computation. Okay, so 4 moles NO2 like this. And how many moles of nitrogen pentoxide? Because that is the one we are asking for, the N2O5. Okay. Question mark. Okay, now, how many moles of nitrogen pentoxide in our chemical reaction? Then look back at the chemical reaction, the final balanced chemical reaction. So there are 2 moles of dinitrogen pentoxide. So 2 moles of 2 moles, okay, of dinitrogen pentoxide. Let's cancel the moles in O2 and moles of NO2. What's left is the moles of N2O5. Okay, like that. Okay, let's investigate, guys. Okay, what the units left here? It's moles again of liter per second. Is this a rate or not? Compare the units with the R1 here. The same or not? If it's the same, so that's also the rate. Automatically, that is the rate 2. Which is the rate of this appearance of dinitrogen pentoxide, and we solve the problem in first attempt only, on the spot. Charot, right? So do the basic mathematics, then okay. Now our problem is the sign. Take note. Wait, we have to investigate first. So 2 divided by 4, okay, 0.5. So 0.5 times 0.0046, move the zeros into the right, 1, 2, 3, okay, is equal to 2.3 times 10 to the negative 3, negative 2.3 times 10 to the negative 3 moles per liter second of dinitrogen pentoxide, which is our R2. Sorry, R2. Okay, like this. Okay, R2. So we have now the R2 here. So no need to solve for the other thing because we already after for the R2. Okay, that is the rate of disappearance of nitrogen pentoxide. Now guys, the question says rate of disappearance of the nitrogen pentoxide. So that's negative because disappearance, it's lost. So this is correct. Negative 2.3 times 10 to the negative moles per liter per second. Now, if the choices in the problems in the future examination there's no negative, okay, then you have to force to choose the 2.3 like this. Okay, unless there is a none of the above. You have also to analyze also the choices. You get the negative 2.3 times 10 to the negative 3 moles per liter second. Okay, this is the answer supposedly, the exact one. So, yes, this appears. And then the choices, there's no negative. So you have to force yourself to choose only positive 2.3 times 10 to the negative 3. Okay, unless there is a choices none of the above. Then choose the none of the above. You got the point? That's gonna be the technique. Okay? Because your answer is negative and there's no negative in the choices. No negative rate. And then the choices also has no example, has no none of the above. So meaning to say the answer is there. So the more closest answer is there. So that is 2.3 times 10 to the negative 3. Only the signs matters. You have no choice. There's no none of the above choice. Alangan mang dili ka mo answer. Got the point? You have no choice really. And it's not allowed not to answer. Okay? Just answer the most closest one, which is the sign positive 2.3, even though the negative is not there. Meaning to say, maybe our analysis is wrong on the signs only, but the figure is correct. Something like that. Okay? So, it's gonna be like that. Take note the word none of the above always. In the choices A, B, C, D, E. And then analyze. Okay, if it's too far, you use the correct formula, logical formula, and you solve it perfectly. And it's not there, and it's very far from the choices, then choose none of the above. Okay, but if your answer is very close, and the only point, decimal point, like this, and then there's no none of the above, okay, and then the sign is reversed, then choose the figure. Okay? Because literally, it's just the same, only the concepts of sign and would matter in that particular issue. Unless there's no none of the above. Okay? If there's none of the above, you choose none of the above. Okay? Because really, guys, there's an answer none of the above. Okay? It cannot be denied. Okay? Really. Okay? What I'm trying to imply, if the choices have no none of the above, then choose the figure which is exactly the same to your answer, even if the signs are not matching. Okay, because the signs only matters on the way how you interpret. Okay? But your solution is correct, magod siya. Okay? Ganon siya. Okay? So that's gonna be the first answer of this problem. Dinitrogen pentoxide decomposes into nitrogen dioxide and oxygen gas if the average rate of disappearance of NO2 is 4.6 times 10 to the negative 3 moles per liter per second. What is the average rate of disappearance of the nitrogen pentoxide? Actually, guys, this is also not really that easy to analyze, but easy to solve. What do I mean by that? Not really easy to analyze, but very easy to solve. How can we justify that statement? Because in here, guys, it looks like very difficult to solve because there's only one given, which is the R. Normally, guys, in problem solving, there must at least two data to compute what is being asked and to compute what is being required. Now in here, it's only one data. How can I do this? Okay, but remember, chemical reactions, stoichiometric relationship matters a lot. The number of atoms and the number of moles. Okay, unless there's no chemical reaction. Okay, so how can you solve that already? Something like that. And the analysis will follow also. There's gonna be not difficult. Okay, that's why I solved this for the first attempt only. Okay, like this. Okay, now problem number 2. Charot. I love this. This is experimentation. Okay. Question number 2, guys. This one. Take a look. Zoom in. Oh, ganon. O, diba? Saya-saya special. Okay, guys. Okay. Here, we're very lucky because the chemical reaction has been shown. But take note. Investigate if the chemical reaction given the problem is completely balanced. Okay, that's the first step. So F2 meaning this is ferrous, F2, because F3 is ferric, plus 2 moles of ClO2. Hala, ClO2 based on my stock knowledge is gonna be chloride, because we have chloride, and the chloride will be subscript 3. And the chloride will be subscript O2, in which this is 1, chloride. Okay? But all raised to the power -1, because chlorate and chloride are all polyatomic anion, negative charge. Okay? So it will produce 2 moles of, I think this is not ferric, because this is only is fluoride. Or fluorine, sorry. Okay, like this. I investigated it twice. This is not ferric, because ferric having small letter E in the besides capital F. It's gonna be like this. Automatically you will change if you commit mistakes. That's a proof that your brain cells are really working well. Okay, something like that. So F2. So this is fluorine. Okay, so fluorine gas, because there's a 2 on the subscript. So fluorine gas, just the same with chloride, fluoride, what else? Bromide, the same behavior. And iodide, right? Iodide, bromide, fluoride, and chloride, the same behavior. A halide group in the periodic table. Ganon. Meaning -1. Yes. -1. Fluoride, bromide, iodide, and bromide. And fluoride. Something like that. Okay? So, fluoride is the main component of toothpaste. Okay? Because it really removes the, the stain in our teeth after we eat due to various substances that accumulated in our teeth, something like that. And fluoride has that characteristic and property to remove those stains or cavity deposits in our teeth. That's fluoride. Okay, and in here it's used here, right? So fluoride plus 2 moles of chloride is equals to 2 moles of fluorine chloride. It's very difficult, right? How can I read this one? FClO2, wait, fluoros. Oh my gosh, fluorine chloride. Help me, guys. Those who take up now chemistry lecture, how can I read this one? Fluorine chloride or fluorine chloride, right? And no other thing. Nakakaloka. Okay, 2 moles of chlorine chloride compound. Ganun lang siya. As long as we know that compound is really that one. Okay? Okay, we balance. So, fluoride. Okay, because F2, fluoride gas. Okay? Just like oxygen gas. Okay? Like that. Okay, so 2 moles of F, 2 moles of F, chlorine 2, oxygen 4. Okay, balance completely. We are very lucky that the problem gives us a complete balanced chemical reaction. Now, we will focus now to the table. Our table composed of first column, the trials 1, 2, 3. The second column is all about the molarity or the molar concentration or the moles per liter. Okay? And then for the fluorine gas F2. Okay, we have 0.10 in the first trial, second trial 0.10, and the third trial will be 0.20. And then the chloride also in terms of molar as our unit also, or moles per liter. This is really the concentration. Okay, in first trial we have 0.010, second trial we have 0.040, our third trial will be 0.10. And then we have also our initial rate. So from the word alone, gas, initial rate, basically this is a initial rate determination method problem solving. It's very clear expressed in the table. So automatically you have already a guide. This is going to be the initial rate determination problem solving in chemical reaction kinetics. Ganon. Okay, so first trial 0.0012, second trial 0.0048, third trial 0.0024. And now our questions, basically 4 questions in this 4 table presented experimentally. Okay, our first question, what's that? What is the order of reaction with respect to each reactant? Second question, what is the overall reaction order, meaning the total? Okay, reactant order A plus reactant order B, or if you have so many reactants, then A, B, C, D, chuba, chucho. Okay, number 3, what is the rate low? Guys, the rate low refers to the initial concentrations, all about trial 1. Remember that one, because this is initial rate determination method. All your rate low and rate constant directly substitution, if you obtain the quantities, refer that to the trial 1, not to the last trial. Okay, the word initial is very important. Okay, like that. What is rate constant? Again, if you solve the rate constant, all about initial thing, trial 1. Okay, that's the technique in solving this kind of problem. Okay, now we go to in here, determine first the rate law or the rate of chemical reaction as our basis, of course. Now, okay, observe in the second column and molar concentrations of fluorine gas. In chemical reaction kinetics class, our purpose is to determine how fast and slow the chemical reaction. And then, how can we determine if it is fast or slow if we will never observe the changes from the concentration? We need to observe the concentration changes from trial 1, trial 2, and trial 3. Now in here, trial 1, trial 2, and 3 in the fluorine gas. In the first trial and the second trial, there's no changes. So, kaliwali. Okay, because there's no changes. Okay? Wale. Okay, now, in the trial 3, there's changes. Right? From initial 1, trial 1 to trial 3. Our basis always is initial 1, the final, and the 1, the second, and the 1. You will never delete the first trial. That's our basis really. That's why it's called initial rate method determination. Meaning to say the initial should always be accounted during the determination of our rate of chemical reaction, or the small r, or the rate low. Okay, now the changes is from 0.10 to 0.20. Guys, other instructors, or some of the instructors, or majority of the instructors in college, they will just say, how much you will multiply this? So in this 1 and 2, from this 0.10 and 0.30. Okay, the approach is basically correct, but the preciseness and the appropriateness of the how you solve is not correct. It's gonna be like this. What is the value of X in the concentration that you let, so that it will be unequal with each other, so that that is the factor you'll be able to multiply to produce the rate in that particular comparison of 1 and 3. So use again equilibrium principle, just like balancing equation. Guys, if you know the principle of law of conservation of matter, you will really pass chemical engineer board examination. Really, because this is really the basis of all. If it involves chemical reaction, guys. especially CHE calculations, stoichiometry, overall material balance, heat transfer, momentum transfer in chemical engineering. If you really understand this, then sure ball you will pass the chemical engineering board examination. Okay? But many doesn't know how to understand this well, because the instructors are always saying what factor you will multiply so that this will gonna be equal to the rate. It's not like that, because that's a trial and error method approach. We don't go for the trial and error method approach in the first place. We should follow the scientific theory in equilibrium with each other. So we will use the trial 1 and trial 3 in equilibrium with each other. Now, trial 1 for fluorine gas in equilibrium with each other. Let X as the factor that we are trying to solve so that we can obtain the rate corresponding to this rate in trial 1 and trial 3. That's gonna be the best explanation during discussion. It's not what factor you'll be able to multiply like this. It's not, because trial and error method is so many. From 1, 2, 3, 4, 5, a lot will be tried. That's why trial and error. Okay? So, it will take you time. Okay? Even though you will start at 1 first, what I mean is that trial and error, for me, second option na lang na siya. Okay, you will just use the equilibrium principle of law of conservation of matter. Okay, now, first trial for fluorine gas. We now determine the rate law individually, okay, for this fluorine gas and the chloride reflected in our table. Okay, let's go first with the fluorine gas. So, fluorine gas F2. Okay, so in this equation chemical reaction, the rate law of fluorine gas will be equal to R, okay, rate constant times close and open parenthesis the fluorine gas, this one, raised to the X, which is the reaction order, in which we don't know yet. Okay, X. Now, we need to find the value of this F2 concentration, the factor we need to multiply so that we can solve for the R or equate to the R, which is also having R here in the 1 and 2. Okay? Now, okay, this is very clear, huh? Okay. Okay, so 0.10, our concentration of F2, okay, times X. Okay, 0.10 times X is equal or in equilibrium to trial 3. Concentration is equals to 0.20. Okay, so 0.10X is equals to 0.20. Guys, our X, we let X is X here as the factor we will be able to multiply in equilibrium also with the rate law here. Okay, now, solve for the value of X. So this is not trial and error method, right? So 0.20, so 0.20 divided by 0.10. 2. So our X is 2. 2 is the factor you will be able to multiply in here. Okay, so this is now, you substitute the 2 in F2 inside the close and open parenthesis. So this will now become R is equals to K times the value of F2 inside the close and open parenthesis. You will put this 2 there inside because this is the factor of the concentration. Okay, so 2 raised to the power X. So we have now the formula of rate law of fluorine gas, which is equal to R is equal to K 2 raised to the power X. And now we need to solve for the R also. Rate. Now, if we use the trial 1 and trial 3, we will use also the trial 1 and trial 3 for the rate. So what is the rate for the trial 1? Which is equal to 0.0012. Okay, like this. So 0.0012 X is equal to 0.0024. We let X as the factor that we will be used in R here to be in equilibrium to the factor also that we use in the concentration. Okay, like that. It's not trial and error. Okay, like that. Okay, so R. So 0.0012 x is equals to 0.0024 in equilibrium. So 0.0024. Okay, so x is equals to 0.0024 divided by 0.0012 is equals to 2. It's the same as 2. Now, this 2 will be substituted in the r. So that you have now the complete equation with values that you solve from our analysis. So this will become now 2 is equals to k times 2 raised to the power x. So now this is our rate law for fluorine gas. 2 is equals to k is 2 is equals to k 2 raised to the power x, in which we determine the x. X is the reaction order. Guys, why do we need this reaction order? Because it is in the question here. And all of the items being asked involves reaction order. If we do not solve this, then we cannot solve what is being asked in the problem. Okay, like that. Now, anong nilubog man ang K, Sir Sotero? Nilubog ang K. Guys, it is a constant. What do you mean by constant? A constant not necessarily mean will be going together in your solution. You treat that as a constant somewhere along the way. So, just drop that it out, because that serves as a constant, okay? Because another reason for that, K is not being mentioned in your table. So it is not our focus of interest muna in the red constant. So just leave that as 2 is equals to 2 raised to the power x simplified. We drop the K because we consider that as a constant. That's why it's called a red constant. Okay, for the meantime, just to solve for our reaction order. And then also another reason, it's not being reflected in the table. Okay, so do not put emphasis for that more on your solution. That's why we drop muna the K. Now solve for the value of x. Exponential method of solving. So 2 is equals to 2 raised to the power x. Again, some instructors will assume numbers in x so that it will be equal to 2. That's okay. Okay? For example, they will let x is equals to 1. So 2 times 1 is equals to 2 and 2 is equals to 2. Assume like this. Me, I will never use that one. Use the calculus for this. Trial and error method is second option only. I know their purpose is to make it shortcut and direct, but the best approach is to use the calculus or the algebra for this. We have the rule for this in ln, natural logarithm. So, natural logarithm of 2, both sides take the natural logarithm. So, ln 2 is equals to x ln 2. Because the rule of calculus, if you have an exponent of x, it will be dropping down as a coefficient beside the ln to a constant. So, now, you have ln 2 is equals to x ln 2. Now, solve for the value of x. So, if you divide both sides by ln 2, now we have the x. Okay, ln 2, cancel. Okay, like that, chuba chuchu. Okay, so like that, ln 2, x ln 2, and ln 2, like that. Okay, guys, ln 2 over ln 2, ln 2 over 2, cancels ln 2, cancels both. Okay, cancels both. What you notice here? X is just equal to 1. Okay, now you have a reaction order which is equal to 1. Put that here. So, your reaction order with respect to fluorine gas is 1. You answer already the number 1 question in terms of fluorine gas. So, fluorine gas reaction order is, so fluorine 2N is equal to 1. Reaction order. So this means reaction order of fluorine gas with respect to fluorine gas. Okay, that is 1. Now we solve that here. Now substitute that x here to 1. So 2 raised to the power 1 is simply 2. 2 is equal to 2. This is correct. I did not use trial and error method. Okay, but the trial and error method is also correct. Try 1. So 2 raised to the power 2 is 2. But the relevance of the calculus or the theory, which is more precise, will be neglected. Go first to the most precise way of solving rather than the direct to the point or the trial and error method. Okay? Unless you don't have any choice anymore. Okay, like that. That's the concept behind. Okay, now we go to the rate law of the chloride, because the chloride also is our reactant. Because we are referring here reactant always in chemical reaction kinetics. Bear that in your mind. Okay, something like that. Okay, let's go now for the chloride. Now, in the chloride, guys, we have 2 moles of chloride. Never raise this to the exponent. This is not the reaction order. As again, over and over again, the number of moles coefficient beside the compound or an element in a chemical reaction, that is not equal to the reaction order. Okay, now, our rate law will become K times, close and open parenthesis, chloride raised to the power Y. Why I use Y as a variable? Because I already done with X. I don't want to put in duplication. The students will be confused. Something like that. I need to designate another letter to avoid confusion. So that's why Y. So R, rate of chemical reaction, or the rate law, is equal to the rate constant times, close and open parenthesis, chloride raised to the power Y. Y is a reaction order in which we need to solve because that is being asked in question number 1 of the problem. Okay, now, how can we do that? We have the chloride initial concentrations here. Take note, are there changes of the initial concentrations of the chloride? Then if there's no changes of the concentrations, initial concentrations of the chloride, then wale. Kaliwali. You will never consider that one. Okay? So, trial 1, 0.0110, trial 2, 0.040, and trial 3, 0.010. So, trial 1 and trial 2 has changes. Go for trial 1 and trial 2. Okay, now, equilibrium consideration. So, initial concentration of chloride in trial 1, okay, which is 0.01, times Y na siya. Because we let Y as our factor to be multiplied with 0.010 to be equated to 0.010 initial concentration in trial number 3. Okay, like that. So times Y is equals to, no, not trial number 3, trial number 2 because there's changes. Okay, quick interception of the error. Okay, 0.01 Y equals to 0.040. So Y will be equal to 0.040 divided by 0.010, something like that, okay? Guys, equilibrium state is very important, or equilibrium principle is very important in solving chemical reactions, stoichiometric relationship, chemical reaction kinetics, stoichiometry, chemical engineering calculations in chemical engineering, okay? Like that. I advise not that trial and error method talaga siya, guys. Okay? Tingnan mo na akong ginabuhat before. I will never consider an option for trial and error unless there's no other choices anymore or options anymore. Okay? Four. Our Y is equals to 4. So this is now our reaction order, which is Y. So we can answer now already here. Chloride has a reaction order. Okay, wait. Y is equals to 4. Substitute first in the equation. Very quick, right? I love this, right? Very quick. Interception of the error. R is equals to K ClO2. Then Y, substitute that there. Something like that. Okay. Now, that is the Y, right? In here, guys, it confuses you, right? Because you let the reaction order as Y, and you let also the factor as Y. Again, quick interception of the error. Okay, now, we need to designate a letter that will not confuse your reaction order. Me, I forgot, I doubled my designation of the letter. I also have Y for my reaction order, and I also have Y in my factor to be multiplied to be equal to R. So, I discourage you, do not do that. Designate another variables for this. It's gonna be, I think it's gonna be Z. So 0.010z is equal to 0.040z for the purpose only that it will never be equal to y because it will confuse. So repeat. Approach number 2. We change the variable so that we can easily understand over the other, okay, designation which is an x. Okay. So z na ta. Kaya itong reaction order na ba guys is y. Okay, so it will confuse. So z is our factor to be multiplied, okay, to be equal to the r in case of the chloride. So z or anything you wanted to, it doesn't matter at all really, sure. Or you can say also directly as chloride if you want to, because we are finding the chloride. That will be more precise. Okay, but let's assume z. Okay, no problem. It's only representation, right? So z, so 0.010z is equals to 0.040. Z is equals to 4. Now, since z will let us chloride, right? So substitute the 4 in the chloride. That's why I told you, use chloride directly also in your equilibrium solution. Okay, because it's just the same. Okay, like this. So R is equals to K. Substitute the 4 as z in the chloride because you represent z as the factor you multiply to the chloride. So that is 4 raised to the power y. Oh my goodness. This is now our rate law. R is equal to K for raised to the power y in chloride. Now, do you have an R? Yes, it's in the table. Now, in the table, you consider the 1 and 2 trials. Consider also the 1 and 2 trials corresponding. If you use the trial 1 also in the initial rate. Ganun siya. Never use the other thing. Okay? If you use those trials, use also those trials to equate. Of course, it's equilibrium. You cannot equate the same quantities. Okay? By principle. Okay, so you use 1, then the rate of 1 is 0.001. So 0, 0, 1, 2. We let that R na lang diretso. Okay? 0.0012 times R is equal to, that is in trial 1. Trial 2, initial rate is 0.0048. So 0.0048. Why I put R, guys? So that we can easily designate to be substituted directly here. It's more better, right? Compared to designating other letters. Okay. So R is equals to 0.0048 divided by 0.0012. Okay, guys. 4. Chararat. Again, review. Because, oh my gosh, it has the same value. Oh, maybe something wrong. Okay, then review. Okay. 0.0048. Maybe I am wrong because it's the same, right? Okay, 0012 is equal to. Okay, your R is also equal to 4. Substitute this 4 in the R here. Okay, so it will become now 4. Okay, and 4 raised to the power by. But review again the z here. Why it's also 4? Because it's rare man good siya na magpareho. That's why I keep on reviewing. Sometimes you will doubt, why it's just the same. Usually it has changes because the concentration changes, and why the answers are having no changes, then you have to repeat, okay, to satisfy your doubt, something like that. Okay, so 0.040 divided by 0.010. Okay, like that. Oh, 4, really perfect. So 4. Okay, so ganon. So our rate law now, guys, is 4 is equals to 4 raised to the power y. We drop again the k for the reason there's no issue in the k in the table. It's not represented in the table. Another reason, we treat k as a constant. That's why it's called a rate reaction constant. So never mind the k muna. Okay, like that. Now, solve for the value of y. This is exponential. How can you compute this one? The same with the fluorine gas. Okay, never use the trial and error method. Actually, we can use the trial and error method directly. You can assume 1 and 4 is equal to 1. Bingo. It's very easy. But we should follow the calculus method, which is the more precise one. So take the ln in both sides, natural logarithm. Okay, natural logarithm ln of 4 is equals to y times the natural logarithm of 4. Then to solve for the y, okay, divide by ln4 both sides so that you can solve for the y. So ln4 cancels, and then 1 is equals to y. Then y is equals to 1. The same in your trial and error method if you will assume that this is 1. 4 to the 1 equals to 4, so 4 equals to 4. But I need only to use the precise, not the trial error method. Okay, so y is equals to 1. Taking the natural logarithm in both sides. So y is equals to 1. So substitute that there in your rate law here, which is equals to 1. Right? Okay, now, your answer number 1. What is the order with respect to each reactant? English, each, meaning the reaction order also of fluorine gas and the chloride. So I have now the chloride, which is equals to 1. So chloride is equals to N is equals also to 1. So meaning to say, each reactant, okay, fluorine gas and chloride respectively has a reaction order of 1. Okay, question number 2. What is the overall reaction order? It's very easy. Add each reaction order. Fluorine gas 1, chloride 1, 1 plus 1 is equals to 2. Ganon. And is equals to the overall reaction order. Okay, number 3. What is the rate law? Oh, solve for the rate law now. Okay, because you have get individually naman good siya. Okay, ganon. So rate law is equal to individual. Okay, R. Basing on this chemical reaction originally, so your R will be a rate law, rate of chemical reaction. This is question number 3. Okay, question number 3, answer solution will be rate law is equal to rate constant K, close and open parenthesis, fluorine gas. Because fluorine gas is the reactant, and the chloride also is the reactant, so chloride. Okay, since in the beginning I assume the reaction order of F2 is X, put X in the exponent, and the chloride also Y in the exponent, and we solve that individually, right? Our X and Y in our computation is always 1, based on your computation substitute. So this is gonna be R is equals to K, F2 raised to the power 1, and chloride raised to the power 1 also. Okay, in that, reaction order is equal to 2. And this is our rate law na. Rate law, R, or rate of chemical reaction, is equal to the rate of chemical reaction constant, or the rate constant, times the concentration of F2 raised to the power 1, and the concentration of chloride raised to the power 1. Or you can simply write that as R is equals to K, F2 times chloride without putting 1, because without putting 1 in the exponent is that the same with not putting 1 in chemistry or in mathematics. It's just the same, unless it is 2 or above, you have to put carefully. But here 1 is just the same as nothing. Okay, that's the rule. Okay, now it's just the same, huh? Now this is your rate law. You answered already question number 3 here. Okay, which is, what is the rate law? O, ganon. Okay, the last, what is the rate constant? This is the time, because it is being asked, then you have to compute, even though we treat this rate constant as constant, of course, by the definition itself, but it is being asked. All you have to do is to solve for the K, and we have the rate law equation here. Okay, then it's being asked by the K, so solve for the value of K. So K is equal to, by algebra, okay, okay, divide both sides by this expression of the concentration, cancels like that, and then it will become R is equals to F2 over chloride O2. Okay, now guys, as I told you a while ago, we solve the rate constant. All values will be basing on the trial 1, because these are all the initials, chuva-chuchu. Initial concentration of fluorine gas, initial concentration of chloride, initial concentration, and initial rate of these concentrations. Do not use the final, or the second you will be wrong automatically. So, substitute the 0.10 molar concentration of F2 and 0.10 for the chloride, and for the initial rate, which is 0.01. Substitute that here, and bingo, you can have the rate constant, which is being asked on the problem. So substitute. So R is equals to 0.00012 over fluorine concentration, fluorine gas concentration, initial and trial 1. Here is 0.01, 0.110 in here, in the table, right? And then the chloride, which is equal to 0.010. Let's do the math. Okay, math, basic math. So 0.10 times 0.010 is equals to 1 times 10 to the negative 3. Okay. 0.00012 is 1. If you have this, simplify, you can have now the answer. So what's the answer? I have the scientific calculator. Okay, so 0.0001. Okay, so 0.00012 divided by, okay, 0.001, okay, is equal to 1.2. Our K is equal to 1.2. What is our unit here? Hala! What is our unit of rate constant? Because we don't carry the units. It's up to you if you carry the units first so that you can cancel out. Or, since this is a reaction order of 2, so what is the unit of K in a rate reaction order? If you memorize, it's gonna be, the zero order is molar per second, which is equal to the rate constant unit. Okay, the first order will be second negative 1, and our second order will be 1 over m times s, or molar negative 1, second negative 1. So better memorize the unit, or you can cancel that out in the equation. In my part, when I was in college, I memorized the units apart from canceling that out in the equation, so that I have two options. Okay, like that. Okay, basing on memorization, our reaction order here, which is 2, is equal to 1 over capital M molar times second, or capital M negative 1 or S negative 1. That's based on memorization, and we don't need to prove this here because we are not inserting the units individually. So all we have to do is to use the 3 option. We have the 3 option for the unit. The formula is K is equals to the molar capital M raised to the power 1 minus N times the T negative 1. So this is the standard formula, guys, in determining the unit of K. Okay, this is an alternative. If you forgot the unit of K because you did not incorporate individual units in your computation somewhere along your solution, then use this third alternative, which is K is equals to capital M molar, okay, raised to the power 1 minus N times T negative. Your N is the total reaction order, right? You have the total reaction order of 2, okay, in question number 2. Then substitute the 2 there. Okay, so K is equals to molar capital times 1 minus 2 times T negative 1. Guys, our T here is in second. Okay, as reflected in the table in the rate molar per second. If it is not second, then follow the what is here, minute, hour. But in here, it's second, then follow the second. Because here is general, only small t in our equation for K. Then you can substitute the second also. So K is equal to capital M. 1 minus 2 is negative 1. And T is second to second negative 1. So this is our unit. Now for the K. So M negative 1, S negative 1. Okay, or the same as 1 over capital M times S in mathematics. Okay, it depends, it's your choice. If it's in the multiple choice that is negative, then see to it that it will be same like this in the choices in the examination. And if it is not in negative, then it is understood to be transposed in the denominator. So 1 over M times S. It's your choice like that. Okay, as long as you understand really the mechanics. Okay. So 1.2 over 1 meter per second. Or memorize that. Because the unit of K in the second order will always be 1 over molar times second, or molar negative 1 times second negative 1. No need to prove something, and no need to incorporate the units chuba-chuchu. Okay? Because you memorize that already. There are 3 options. Memorize the unit of K in each order. Second, incorporate each individual units to cancel that out for the unit of K. And the third, use the formula K for the rate constant is equals to capital M molar raised to the power 1 minus N times T. You have 3 options, right? That's impossible. You will get the correct answer for the units of K. Okay? Do not depend only for one option. Remember, use the three options. At least you know how to adapt these three options for your own convenience or choice for your convenience, something like that. Okay, in my comfort, really memorization. Okay, because it's very quick. You don't have to prove, you don't have to cancel that out, and it can also be identified because you can really, analyze the unit somewhere along the way. Okay, something like that, because you know the unit of a rate constant, you know the unit of the rate law, you know the time, then we can go something like that. Okay, so that is our rate constant here is equal to 1.2 over meter per second. Now, in your part also, you can correct me if I'm wrong. Okay, then you can solve by your own. And we will issue error statement for this particular vlogging if my answers are wrong in questions 1, 2, 3, and 4. Okay? Now, guys, 1.2, Okay. Now, our rate here is 0.0012. Guys, rate is 0.2. And then, in the second trial is 0.048. And in the third trial, 0.002. From high, go, meaning to say your concentrations also will not be steady. It's also changing because your rate law is changing. Because rate law and initial rate of concentrations, or the concentrations, final concentrations, are directly proportional to the initial rate. Okay, something like that. Okay, you get the point? So that's it. If you like this vlogging live streaming, you can comment down below in the comment section, and you can subscribe my YT channel if you like, and then click the notification bell for some newest updates. I am a singer, eternal voice. I am a singer, eternal voice. Bye bye, God bless everybody. See you later. Woo!